burner switch, which is in auto right now. Okay, the automatic switch, basically what it does is when you turn the boiler on, you flip the switch on, and basically what it is, it provides air to the burner so that there's a purging. You have a thing called secondary air, you have a thing called primary air. Okay, primary air is when you're burning number 6 fuel oil. When you're burning number 6 fuel oil, basically what that is oil has to be itemized, meaning that there's a proper burn pattern that goes inside of the combustion area when you're burning number 6 oil. This boiler has 2 agents, natural gas and the oil of number 6. Okay, so if I'm atomizing oil, you can't just flip oil into a boiler. When you atomize it, it actually blows the oil into the combustion area and burns it properly. Okay, and number 6 oil is a heavier grade of oil. Okay, it's thick, but you get the most BTU content out of it. I've worked with number 4 oil, I've worked with number 2 oil. Number 2 oil is light, okay, you don't get as much BTU content. Number 4 oil is a little bit heavier, but again, the BTU content is much lighter in that. Number 6 is a heavy, thick grade of oil, and it's hard to atomize it. You have to actually heat that oil 24 hours before actually using it in the system. Okay, but you get more bang for your buck out of that particular oil. That's why number 6 oil is more commonly used in power plants. So this is the air burner inside. We have air dampers inside also. Those switches have to be flipped in order to properly operate the system. Okay, right here we have our breaker switch. We have our draft indicator. And again, the airs. Primary air was for the combustion area. Then you have forced draft and induced draft. This particular hood right here, I don't know if you can see it. Basically what it is, this hood right here is your forced draft. What it does is it brings the air into the combustion area and it brings it into it to where it can actually push the flue gases through the heat exchanger. From the heat exchanger after it's been blown out through the stack. And you have normally, in some cases, you have an induced fan also, which takes the flue gases that have been blown through the combustion area, and it takes it and it sends it up the stack. So you have one that's pulling it, and you have one that's pushing it. Basically, there's a dual purpose with that because you want to make sure that all the gas is out of the combustion area. Okay. Draft. This draft gauge right here just tells you exactly how much air is going through the system. That's the purpose for this gauge right here. And usually, in most schools, we have startup procedures, startup and shutdown procedures, and checks that we normally go through on each shift for every operator, every engineer that comes on board for their shift. Okay. Right back up here. Okay, now. So, I'm going to take you into the middle here. I'm going to angle it so that way you can see exactly what I'm talking about as far as blowdown is here and safety devices and warning devices. So, let's go ahead and get you in there as well. Right here. These are all your blowdown devices here. Okay. What we're looking at in this particular instance is we have the water column, we have the gauge glass assembly, we have the tricox. Okay. Each one of these functions are very important throughout your shift. When you're operating, it's very important that you go through these checks. Okay. First thing that I do when I come into the boiler room, I blow down my water column and gauge glass. When you blow down your water column and gauge glass, what that does is you can determine how much water is actually in the boiler. When you blow it down, it actually cleans the water. It actually balances the chemicals inside of the boiler. Goes down, it flushes, it comes back up, reestablishes the water level. The tricocks also are another means of checking the water level inside of this boiler. Basically what it is, the water level inside of the boiler can be determined 3 ways. Water column, through the tricocks. When you pull the lower tricock, you get all water. When you pull the middle tricock, you get a mixture of steam and water. When you pull the top tricock, you should get all steam. And that gives you the proper indication of what's actually inside of the boiler and inside of the water column. The purpose of the water column is to reduce the turbulence so that way you can get an actual reading inside of your gauge glass. Without that, it would just be water flopping around inside of it, so you never could get a proper reading. Okay? Then your gauge glass is the secondary means of checking the water level. I'm sorry, actually it's the first way to check the water level. The tricocks are the second way. Because if you ever break your gauge glass, you can always check it by your tricocks. So the tricocks are your secondary means of checking the water levels. After you've checked them, you have these valves here, okay? And these valves are very important because what you do, and what you can do, is you can open up each one of these valves according to the blowdown, to that accessory. If I'm blowing down my water column, well, this line right here would do it for me. If you watch the connection, if I'm just going to angle up so you can see, if you see the connection here, looking up, okay, right there, there's your water column, and then here is the line that comes down to it, okay? This is your line right here, and this is your blowdown for that, okay? And let's look up, there's your tricocks, they are attached to these chains here, and each one of these represent exactly what this boiler is supposed to produce, okay? Then this is your blowdown line here at the bottom, which actually goes from your low water cutoffs here and there. They're all attached to this line, and then they all go out there. And then on the back of the boiler, we have a bottom blowdown, okay? And that's the reason why that's so important, because each one of those blowdowns and each one of those lines serve a purpose for that reason, okay? So it's very important that you do your checks when you come into the boiler room every day, okay? I think that's very important that you do that. Now, we have 2 boilers here. I figured I would take the time because when I run the boiler, it's kind of hard for you to hear me, so I'm leaving it off so that the proper illustration can be demonstrated, okay? So, we, again, are going to look inside the control panels to each one of these units. Here, inside of this control panel, this is your manual and low fire. Right now, this boiler, if it was online, it would be on low fire. If I wanted to put this boiler on high fire, I could actually flip this switch to auto. If I flip this switch to auto, this will actually override and automatically go into high fire status. Okay? These are your controls. This is your control switch for off and on power. Okay? Let you know that it's on. Call for heat, meaning that when the boiler shuts down for, say, by the pressure troll, which is actually at the front of the boiler, we're going to talk about that in a second. When it calls for heat, the light will come on and the boiler will actually go into the post purge and ignite. This is your ignition valve here, or ignition indicator. This is your fuel valve, which means that the gas in the line, which is here, okay, basically puts the gas into the burner, which is here, okay, at the right time after it's been purged by the blower motor. this is your low water. This gives you an indication of low water indication in the boiler, such as the gauge glass there. Okay. Here you have main flame. Main flame is determined right here by the burner section. There's your gauge, tells you exactly how much gas pressure is going to the boiler, and then there's your supply right there, the orange line going into the burner section. This is the fuel transfer. Now again, I mentioned it, that you have oil and you have gas. Now, we're running gas, we're not running number 6 fuel oil. If we were running number 6 fuel oil, then we could actually flip this switch over and we could run oil at that point. Then a lot of times if we have a low water condition, this alarm will go off. And if this alarm goes off, we can actually push this button and it will silence the system, so that way we can reset. And this will be your reset button here. Okay, so that's pretty much what's inside of the control panel. Okay, now let's take you up top. Up top right there you have your steam gauge or pressure gauge. That pressure gauge is very important because we have pressure controls on boilers. And these pressure controls are very important because the pressure controls are wired to control this burner unit. Whatever the pressure control is set at, let's say the pressure control is set to kick in at 2.5 psi, then the pressure when this boiler is actually running will start at 2.5 psi. When it reaches, let's say, a cutoff pressure of 5 psi, and if that's the setting on the pressure control, then on the top of that gauge, 5 psi will be when the boiler will actually stop. It'll shut down, it'll go through a post purge, and then it'll wait for the call for heat. Now, I never ever just go by the pressure control alone. In some cases, I go by temperature. If I get to 5 psi on my boiler, that means I've reached a certain temperature. 5 pounds of steam is exactly how much steam is needed inside of a school district. Okay? Anything more than that usually is too much steam. Sometimes it'll be too hot. Okay? But basically what this is that in a school system we run 5 pounds of steam, and 5 pounds of steam is adequate enough. So what we do is we set the pressure control, and that pressure control can be set at 5 psi to go off at 2 psi. And at that point, usually I reach around about 180, 200 degrees in heat pressure in the system. At that point, when I reach that temperature, I know that my boiler is at 5 psi, and everything is functioning the way that it should function. So that pretty much concludes this segment. I wanted to put a part 2 on it. So I'm Eric Fluker. Hope you enjoyed the show. Peace.